Good evening, welcome back to my kitchen. Let's do some more scientific notation stuff. I wanted to compare the size of things using quotient of powers in scientific notation. So first, check this thing out. Have you heard of the Large Hadron Collider? It's this thing in Europe that, without knowing a whole lot about it, essentially it's a really long tunnel and they smash electrons together. There was a big conspiracy that maybe it was going to start a black hole and coincide with the Mayan calendar in 2012 and destroy the Earth. It didn't happen. We're going to use it to talk about energy and really small units of measurement. You'll see there that the Large Hadron Collider continues operations, ramping energies to run at 3.5 TeV. Don't know what the T is, but you'll see electron volt there. That's what we're going to look at. Electron volt is a unit of energy equal to approximately 1.6 times 10 to the negative 19th joule. Joule is a basic unit of energy that you'll use in chemistry class. So let's deal with joules of electron volts. There, we already saw that an electron volt is a measurement that the Hadron Collider is dealing with, and it's equivalent to about 1.6 times 10 to the negative 19th joules. Let me write that down real quick if I have enough room. There's my 1.6. My decimal point would be here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Honestly, I don't know how much didn't get recorded there. Messed that part up. Just to recap. Let me get a different color. I'm comparing here candy bar energy being 1 times 10 to the 6 joules. Electron volt energy being 1.6 times 10 to the negative 19th joules. The first thing I did was I used the negative exponent rule to get that up into the numerator. The negative exponent was only on the 10, not on the 1.6, so I left the 1.6 down here in the denominator. I used my power of products rule to take 6 and 19 and turn them into the 25th. And now I'm just going to calculate whatever this is. 10 to the 25th would be 1 with 25 zeros over behind it, divided by 1.6. No reason to not just use your calculator here for that. Okay, so I'm going to calculate that, just using my calculator. Got 10 to the 25th divided by 1.6. What did I get? 6.25 times 10 to the 24th. Let's write that down. If I've got the space, 6. The 2 and the 5 are 2 of my spots, so I need 22 zeros here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. We did it. Comma, 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 comma. 62 whatevers. More energy in a candy bar than in 1 electron volt. Again, welcome back to my kitchen. Here we are, still talking about exponent powers. We just looked at how much larger, how much more energy a candy bar had than the energy in an electron. Let's go back at the scale of space. Earth is way smaller than Jupiter, but I wondered how much smaller. So I looked up the volume of Jupiter and the volume of Earth, and we're gonna do some exponent rule calculations, scientific notation calculations to check on that. Just for comparison's sake. Here's Jupiter. I'm sure you've seen it in science class. You've got that storm there on the bottom right. Here's a website that compares them all to scale. There's the sun. You see Jupiter there, and then Earth. Much smaller. But how much smaller? Let's calculate. The volume of Earth is, I'm in trouble. I forgot to write down my units. The space website I found this on said it was 108.321 times 10 to the 10th. But you know from being good scientific notation students that we can't leave it like that. We have to have the first digit be a number 1 to 9. So if I convert that, I need to add on 2 more exponents, and we'll call that times 10 to the 12th. The volume of Jupiter was listed as 143,128 times 10 to the 10th, which we know we shouldn't leave that way. So following our exponent rules, we need to call this 1.43128 times 10 to the, how many exponents did I add on? 1, 2, 3, 4, 5. So that needs to be 10 to the 15th. So what we're comparing is 1.43128 times 10 to the 15th and 1.08 times 10 to the 12th. Let's clear those out of the way. One point 43128 times 10 to the 15th. And that's the Jupiter, mass of Jupiter, in units that I forgot to note. Mass of Earth, sorry, volume of Earth, excuse me, 1.08321 times 10 to the 12th. This is just a quotient of powers. I need to subtract my exponents and divide this other number. When I just divide that, dividing the two constants in front, I came out with 1.3213. Let's do our exponent rules. Let's subtract these exponents. Got 10 to the 15th and 10 to the 12th. I'm going to be left with 10 to the 3rd. So this is bigger by a factor of 1321.3.